Hello everyone, hey guys, this is me, your educator Megha, and today we are going to talk on a very important topic from GOC, that is the mesomeric effect. What is mesomeric effect? Many of our times students confuse between the resonating effect and the mesomeric effect. So are they different or the same? So what is the minor difference between the two? Okay, and when we are talking about the mesomeric effect, okay, this is of two types, that is the plus M and minus M. So we are going to look over that what is this plus M and minus M effect. Okay, so guys, I hope this session is all live and I'm audible to everyone. So if everything is going well, please do let me know so that we can continue with the session thoroughly. Hello Shriyanshu, all going well, bachche? So what are the things that we are going to focus? First of all, we will start with the mesomeric effect, and then after I will also be telling you about many of its other factors, that is what is its type. Then I will be taking a very important comparison, okay, that how we can compare between the mesomeric structures. I will be telling you, and the best comparison. I will be taking two examples and they will be best comparing between the plus M and minus M, and it is going to be like extremely helpful. And in last I will also be taking your doubts if you will be having any. So guys, I hope you got a clear idea that what we are going to have in this particular session thoroughly. So why not, let's start it now. Is it achievers guys? Shriyanshu, I can see. Hi to everyone. Mesomeric effect is basically the property of a functional group. Okay, so let me take an example for you to make you understand. Here I have taken this as a compound which is a benzene. Okay, and here I am putting any of the functional group, any functional group you can put, whether you put OH or you put this is creating a problem. Why is this so? Pen. This is the issue of a pen. Let me change the pen. Just a minute. Okay. So guys, here we have started. Okay. So yeah, this is working a bit fine. No, it's not working. Just a minute. Just a minute. Just a minute. Hey guys, I hope now everything works fine. Let me check it first. So yeah, now I am able to write. I think it will work properly. Is it? This is going to be a half an hour or 45-minute session, achievers. Okay. So guys, here we start the resonance and aromatic compounds. So first of all, as the name says, resonance we are going to see in the aromatic compounds. Means the aromatic compounds are those compounds which are having this kind of a benzene ring. Okay, and over this aromatic compound we are going to see the mesomeric effect. So first of all, let me tell you guys, mesomeric effect is the effect of a particular group which is attached to a conjugated system. So whenever any particular group is attached to a conjugated system, that becomes a mesomeric effect. Okay, so if you will see simple benzene, in a simple benzene you can see that there is a delocalization of electron. So ultimately in a benzene you will say that there is a resonance. Will you say there is mesomeric? No. You will simply say here is a benzene, there is a delocalization of electron over all the carbon compound, all the carbon atoms which are a part of a conjugated system. Okay, so this is a resonance. But what is the difference? Now here we are going to look, so the mesomeric effect is the property of a particular group, that is any functional group or any substituent which is attached to the conjugated system. Okay, so the mesomeric effect is the property of that particular group. So this is the very basic point of difference that one needs to know, that what is resonance and what is mesomeric effect. So again, let me tell you, mesomeric effect is the property of a functional group, either the functional group or the substituents within a chemical compound which are a part of a chemical compound. Okay, so here if I take an example, again it is doing something like this. I hope this will not create an issue. Oh my god, Why is this so happening over this particular slide? Okay, what if I draw it there? Um, this way it would be very difficult to form bonds for all of you. I am trying to form O and it is not getting O, it's getting triangle. How to correct it? Let me see. Activating groups. So here this is not a problem on this particular slide. I think there is some issue is there over this particular slide. Okay, so we can avoid it. Okay, on this particular slide only there is an issue. So rest this will work, I think. So mesomeric effect is the property of a functional group or the substituents which are a part of a chemical compound. Okay, so just assume if I take a benzene and over a benzene, yeah, I am trying to prepare a benzene, and over that benzene if I put any group G, so that is the property of that functional group, or any substituent, whether I put chlorine, bromine, iodine, or I put any kind of methyl or isopropyl group or any kind of OH, NO2, NH2, any kind of group if I put over that particular benzene. So this mesomeric effect is a property of that functional group. Okay, this is it. Now if you want to know that what is this it's a definition, guys. When I'm talking about the mesomeric effect, then why I have written resonance in aromatic compounds? So basically the resonance in aromatic compounds is said to be the mesomeric effector. So basically what happens is, if I am talking about a conjugated system, now just see here I am going to take an example for you which is of NH2. Okay, I hope it's clear to all of you. So this is described as the polarity developed between the atoms of a conjugated system by the electron transfer or pi electron present at the adjacent atoms. So here we have to look for the polarity. So if you will see its resonating structure, I will be telling you on the next slide in detail. So if you will see the conjugation, then what you will found that the lone pair over the nitrogen will undergo resonance. Okay, and ultimately we will be getting a double bond. This will become positive, and over this pi bond will be broken, and so therefore here we will be getting a negative charge. So ultimately there will be a polarity that will develop between what? Between the conjugated system. So here we are having a polarity, that is here we are having a negative charge, and here we are having a positive charge. So this is a polarity that has been developed between the conjugated system. So we can say that this benzene is basically a conjugated system and the adjacent atom. So what I mean by the adjacent atom? Between this particular atom which is the adjacent to this benzene ring. Okay, so here let us see again that what are the activating groups and what are the deactivating groups. So again I will be telling you, as I hope here I will be able to tell. Okay, so what I was telling you is, this is the polarity developed. If I take an example of this benzene with NH2, yeah, on this particular slide everything is fine. So benzene with NH2, so what has happened is, so when I look for this lone pair of nitrogen, now see, if you are talking about only an benzene, yeah, there is a delocalization, complete delocalization. This is a conjugated system. So all the pi electrons are getting resonated. Okay, so here within a molecule, if we are talking about the carbon-carbon atoms and the conjugated system, this is known as a resonance. But if I want to see the effect of that particular group, that how this group is behaving, so if I will be having a focus over this particular group, then what I will be finding is that this nitrogen's lone pair and this pi bond will undergo resonance. Okay, now this pi bond and this lone pair of electron will undergo resonance, and so therefore this will go this side and this pi bonded electron will go over this particular carbon. So ultimately what will happen? This will form a resonating structure which would be something like this, that is double bond NH2 positive, and here over this carbon we will be getting a negative charge. The bond has been broken, rest all the pi bonds will remain as it is. So ultimately what has happened? There is a polarity that has been developed. So mesomeric effect, what is mesomeric effect? There the polarity develop. Okay, now the polarity is developed between whom? Between the conjugated system. So here we are having a polarity between this conjugated system, This is your conjugated system, and the polarity is developed between the conjugated system and the adjacent atom. Now we are talking about that particular atom which is directly attached to the benzene ring. I mean to say that the polarity developed between the adjacent atom means the atom which is directly attached to the benzene ring. So this is the atom which is directly attached to the benzene ring. So I am talking about the nitrogen. So this is the polarity developed between the conjugated system and the adjacent atom. So how this polarity develops? Now see over the definition what I told you, by the electron transfer or pi bond present. So how this polarity is developing? Because of the electron transfer. Now just see, here over the nitrogen we were having a lone pair of electron. So this lone pair of electron, this electron will transfer. Now if I ask you, you know na, this is a conjugated system. So whenever I told you in my one of the previous video on resonance that whenever we have this kind of system, X double bond Y single bond Z. So this is a pi bond, and over this particular Z, if we will be having any kind of electronic system present, whether it is a lone pair or it is a negative charge or it is a positive charge or it is a pi bonded system, then we will be having a delocalization. Okay, then we will be having a delocalization. So ultimately this is a lone pair and it is undergoing delocalization. Are you getting the point? Okay, and so therefore the polarity develops, and ultimately this nitrogen is causing the mesomeric effect. Now the question is that what type of mesomeric effect is this? Whether it is a plus M effect or it is a minus M effect. Are you getting, guys? Okay, so to know this, ki whether it is plus M or minus M. Now the plus M effect, also known as the activating groups. So when I am saying the activating groups, usually guys they are activating towards electrophile. They are activating towards electrophile, because if you would see a benzene as in whole is a nucleophilic in nature, so it will be activated towards the electrophile, and these groups are also said to be the ortho-para-directing. Then why we said them the ortho-para-directing? Let's have a look. So here I will be picking up the same example which I have taken, that is of aniline, benzene with the NH2 as a group. So if I want to see, this is my conjugated system and how this group is behaving, that is the nitrogen. So what I focused over is, I looked over, okay, this is a pi bond of my conjugated system and this is the electron that we are having. So how they will be formed? They will be undergoing the conjugation or the resonance. How they will be the electron transfer? Now guys, we always know that the lone pair is a good donor. So this lone pair will try to give its electron to this particular nitrogen, and this pi bond will be broken in this particular direction. Ultimately, we will be getting a system where we will be having a benzene, this pi bond has to be broken. So ultimately we will be having a negative charge over there. Here we will be getting a double bond and this will become NH2 positive. Okay, and the rest 2 pi bonds will be there. Now again, this is not yet over. Okay, this is not yet over. Again, what we can do is, now here we can see that this negative charge and this pi bond, they are again in conjugated system. So X, let's say this is my X, this is double bond, Y single bond Z. So again they are forming an XYZ system, and for the resonance to occur, the XYZ system is necessary. So again the electron transfer will occur from this to this, and this pi bond will be broken in this direction. Okay, so at this particular carbon X, Y, Z, okay, only the electron electron will resonate between the XYZ. Okay, so ultimately what will happen? We will be getting a system with a negative charge over there, and this will be a pi bond, double bond NH2 positive. Is it clear to all of you? Now again what we can do, let me again pick a green color for you, that would be nice to explain. Now guys, here we are moving from this to this, no, we are doing an anti-clockwise rotation. So let's move in this direction only. Now this negative charge and this pi bonded electron, they are again forming a system X, Y, Z. So let us see what is happening between X, Y, Z. Now this pi bonded electron will get broken and the electron density will transfer over this particular carbon. Ultimately what we will be getting? Now please have a look, you just have to make a change there only, where I have shown the electronic movement. Ultimately here we will be getting a pi bond, this pi bond has been broken, negative charge we will get, and this is double bond NH2 positive, means the rest part will remain the same. So this is it. Now the question is not yet over. Still we have one more possibility. This negative charge and this pi bonded electron again forming a conjugated system, that is X, Y and Z. So ultimately this negative will go here and this pi bonded electron will go here to neutralize the positive charge over the nitrogen atom. So ultimately the last and the final structure that we will be getting here would be, this will be the pi bond, the bond will be broken, we will be getting NH2, and now the positive charge over the nitrogen is neutralized. So now is there any other possibility? No. So now what is happening, we are not just having a conjugated system, that is a benzene, we are also having a group attached to it. So how this group is behaving, whether this group is increasing the electron density over the benzene or this group is decreasing the electron density over the benzene. We all know that the benzene as an individual is nucleophilic, but I want to know that what type of effect this group has caused. This group has increases the electron density over the benzene. So because of this NH2 group, I can say that because of this NH2 group, the electron density on benzene increases. So if the electron density on benzene increases, then what can happen? This would be known as the activating group. Means we would say that this is an activating group, this is activating our nucleophile, this is activating our benzene ring. So now the question is, this is activating our benzene ring, but towards what? So guys, when there will be an increase in electron density, now I may show you this thing ki here, because of this group we can see that over the ortho para positions, this is our ortho and this is our para, ortho meta para. I hope you know the positions of a benzene. If over a benzene we will be having any group attached, then this is your ortho, this is your meta and this is your para position. So if you will compare in between the three positions, you will find that the electron density over the ortho and the para position is quite more. So ultimately it will be more reactive towards the electrophile. It will show its more reactivity towards electrophile. So that's why we are saying that this is an activating group towards electrophile, which is very necessary to understand. So this is activating, but for what? For electrophile. Okay. So ultimately the product so formed here would be, the electrophile can either attack over this ortho position, this will be the product, or this electrophile could attack over this para position, that is here we can do the attack of an electrophile at this para position. Now if you would ask me, ma'am, what about this ortho? This ortho and this ortho is the same. So whether you attack, this is also two electrophilic substituent, this is also two electrophilic substituent. Okay. So whether you attack over here or you attack over at this particular position means the same. Okay. So ultimately we will be getting two products, that is one will be the ortho substituted or the other will be the para substituted. Now which is more stable, which is less stable? There are other factors that we have to focus, that which will be more or less stable, that I will be discussing in my further lectures. So guys, you all understood what is this plus M effect. So if any effect that increases the electron density over the benzene ring, that is activating in nature, which is activating group and activating your benzene ring towards electrophile, or any of the group which is increasing the electron density specifically over the ortho and para positions, and so therefore this will be known as the ortho para directing group. Now if you would see any of the group, like whether it is O with negative charge or the nitrogen with simply a lone pair of electron, because of course when you will be having a benzene ring and you will be putting any kind of nitrogen, this is the hydrogen and this is the R, of course we will be having a lone pair, and this lone pair will try to increase the electron density over the benzene ring. So again it is going to be the plus M effect. If I will be having the OH group, guys, you know, over the OH group also, if I will take a OH group, I can say that OH group is also having the lone pairs present. So because of this reason, this is again an XYZ system, and this lone pair again undergoes resonance. Okay, so we have to see the polarity develop between what? Between the conjugated benzene and the atom which is directly attached to the benzene ring, that is the adjacent atom. Again, let me make you repeat. The polarity develops, so we have to see the polarity, where the polarity is developing, where the positive negative is developing between the atoms of a water, of a conjugated system of my benzene and the adjacent atom. okay, and the adjacent atom. So what does this adjacent atom means? Means the atom which is directly attached to the benzene ring, okay. By how? By the electron transfer or the pi bond that has been present. Okay, now if you will be having any kind of OR, absolutely OR, again we will be having the O attached, and this again O, this behave in the same pattern. Okay, so here again we have a lone pair of electron, this will undergo resonance. If you will be taking this kind of group which is NHC double bond OR, now what can happen in this particular case? Let's have a look. So guys, what we have to see? We have to see the polarity developed. This is N, so here if I am saying NHCOR, so from here I am forming a bond with the benzene ring. So this is NHC double bond OR. So where I have to see? Guys, if you are seeing the mesomeric effect, then the mesomeric effect is between the polarity developed between the conjugated system and that particular atom which is directly attached to the benzene ring. So we are talking about the conjugated system and this nitrogen we are talking. Okay, so if you would see, this nitrogen lone pair will again undergo resonance in this particular direction. So again it is increasing the electron density over the benzene ring. So we would say that it is again activating towards electrophile. It is again increasing the electron density, and hence it is an activating group, or it will be the ortho and para-directing. So if you will put any of these groups, they will behave in the same pattern. They will behave in the same pattern. Okay, so the mesomeric effect is the effect of a group over the conjugated system, over the benzene. That's why I named this session as resonance in aromatic compounds. Okay, so if you are like confused at when to put the mesomeric effect, always remember, whenever we will be having a resonance in aromatic compounds, that would set to be the mesomeric effect. Okay, so I hope. Electrophilic means positive, absolutely, means anything which is electron deficient in nature. Okay, achievers guys. Okay. Okay. So now let's have a look over the minus M effect, that what happens when we will be having a minus M effect. What type of groups are said to be minus M, and deactivating groups or meta directing, what does this all mean? Okay, so let me take an example for you all. Okay, now guys, I will be taking a very good example, that is again here I am having NO2. Now you see, in that particular question also I was having N, and here also I am having N. So what does this mean? Guys, just wait, you will be learning a lot from this particular question. So this is my group G, okay, and this is my conjugated system. This is my conjugated system. So I want to focus that where the polarity is being developed between the conjugated system and the atom which is directly attached to the benzene ring, that is the adjacent atom. So I want to see the polarity that is being developed, the polarity developed between this conjugated system and the atom which is directly attached to this benzene ring. So I want to see the polarity between this atom and this benzene ring. Okay. So guys, here if you will see the nitrogen's valence shell electrons, then you will find that nitrogen has 5 valence shell electrons, 1, 2, 3, and the fourth and fifth, these two electrons are forming a coordinate bond with this O. So is this nitrogen having any lone pair present? No. Over this nitrogen there is no lone pair present. Now if there is no lone pair present, because nitrogen is having 5 valence shell electrons, 2 are undergoing bond formation with this oxygen, 1 is undergoing bond formation with this oxygen, 1 is forming a coordinate bond with this oxygen. So nitrogen is not having any lone pair of electron. Then who will participate in resonance? So guys, here if you would see this question, here the double bond of this NO2 group. So what? The double bond of this NO2 group. So over the nitrogen we don't have any lone pair of electron. So the double bond of this NO2 group, that is the over this nitrogen, this double bond is attached, this and this will participate in the conjugated system. And now we will see that where the polarity is developing. Now if you would see, now you tell me, this is a pi bond, this is a pi bond. They have to undergo conjugation, that is a delocalization of pi electron we have to do the electron transfer. So how the electron transfer will occur? Guys, this this is a C double bond C, which is a non-polar pi bond, and this is the N double bond O, which is a polar pi bond. So always polar pi bond breaks first. Polar pi bond is quite weaker and it will be broken first. Now if you would see, among the nitrogen and oxygen, oxygen is more electronegative. Ultimately this will pull the electron towards itself, okay, and so therefore this electron pair will go in this particular direction. Now again you can see that we do have a X double bonded Y and this is Z. So X, Y, Z system we still are having, and over the Z we are having a pi bond, okay. So yeah, this is forming a conjugated system. Is it clear? Now if I do this kind of resonance, then what I am getting? Now what I am getting that this is N and this is O, and this will become O negative because this O is pulling the shared pair of electron. So this is becoming O negative, this is double bond, and here we will be getting a positive charge, and rest of the bonds will remain the same as they were, okay. So the major difference that you have noticed in this question and the previous question, what was that? Please check it thoroughly. Here in this particular question, the pi bond of this nitrogen participating in the resonance, okay, but in the previous question, here we were having nitrogen with the NH2 group. So here we were having a lone pair. So this lone pair was participating in the resonance. So ultimately lone pair is donating in nature. The lone pair always gives its electron pair, but this kind of polar pi bond always takes its electron pair. So please have a look, have a focus over this major part that I am doing. Here this is giving its electron pair, but here this pi bond is pulling it this electron pair. So this is the major difference. So we can't say that anything is plus M or minus M just by looking over the nature of the atom. This is nitrogen. No, this is not the property of the atom. Okay, this is the property that how the electron transfer is occurring. Okay, how the electron transfer is occurring, whether the electron transfer is towards the benzene ring or it is away from the benzene ring. This is what we have to focus. Now I think this is very, very clear to all of you. We can move forward now. Okay, so till there we reached. Now we will be moving forward, looking for what we can do next. So first of all, the oxygen has pulled the electron towards itself. Ultimately we got this positive charge. Now this positive charge, this single bond and this pi bonded electron, again forming a conjugated system. They are again forming a system that is the same system, X double bond Y single bond Z. Whenever we will be having a positive charge, the electron will move in this particular direction. The direction, yes guys, the direction, this is a vector quantity. We have to focus over the direction of the electron transfer, okay. So here the electron transfer is occurring in this particular direction, and so therefore we can say that this pi bond will form, and here we will be getting a deficiency because of course this pi bond is getting broken and rest of the bonds will remain the same. So just form the same way we have to do. This will remain as it is, this will remain as it is, and this is again a pi bond. Now again what we can do, let's have a look. This is a positive charge which I have noticed again, and this is again a conjugated system, a positive and this. So again we have a three atoms, X, Y, Z, the three atoms that shows resonance. Again what will happen, this pi bond will be broken in this direction, and so therefore the positive charge will get neutralized. Ultimately what we are getting, here we are getting a bond, and this will be getting a positively charged double bond N, this will be your O, and this will be O negative, okay. Rest everything will remain the same. Now if you will move further, now what you can focus guys, here I can focus that this positive and this double bond is still in conjugation. They are still in conjugation. So what we can do, this will form, this pi bond will be broken in such a direction, again forming a system X, Y, Z and X, Y, Z, Z with a positive charge. So ultimately I can draw one more resonating structure which would be something like this. The pi bond is giving its electron density to this particular bond, and over the nitrogen I will be getting a positively charged, and this will become O negative, and this is O. Now guys, now you would say, ma'am, this is positive and this is negative. Now how they will be undergoing resonance? No, there will be no resonance. Now guys, you know what is electromagnetic effect? Electromagnetic effect is the temporary effect, and there we will be having a breaking of a pi bond. So can't you say that this O negative and this N positive, if we will be having the two opposite charges more closer, okay, so they will be attracting towards each other and will form a pi bond. Absolutely. So this is an electromagnetic effect, okay. So just because of the electromagnetic effect, there could be a breaking of a pi bond, there would be the displacement of the there would be the displacement of electrons in this particular way. So we can also form a bond, so we can replace, we can neutralize these charges. So opposite attracts, and so therefore they will be forming a bond together, okay. So ultimately I can remove this negative or positive, or I could say that I just draw the structure in such a way so that you people don't get confused. This and this will become N double bond O. So ultimately this and this structure, okay. So this is not a new structure, this is the same structure, okay. So you understand the difference that I have shown by the double headed arrow. So what does this difference says? That this double headed arrow says that these are the resonating structures, okay. So basically all the resonating structures are the non-real structures. The real structure actually lies in between this, which we can't see and which we can't draw actually, okay. So that's why we are drawing it like this, okay. So these are the extreme conditions, and between all these conditions the actual structure is basically existing, because it is a delocalizing, no, it is keep on moving, keep on moving, keep on moving. So if they are keep on moving, so their position is very uncertain, so it's very difficult to find out the certain position, okay. So that's how we have tried to form the extremities of those particular structures, okay. So here we can say that this structure number 1, structure number 2, and the structure number 3, this is the structure number 4, the structure number 5, they all are the resonating structures, they all are the resonating structures. But can you say this? No, this is the same as that of this. So this sign is for the equivalency, equivalent, okay. So this and this are actually the same. So these are the 5 structures that we will be getting from that particular nitrobenzene. Now why it is said to be the minus M effect? As you can see what it is doing, if I would see that okay, nitrobenzene in your presence, what is happening? In the presence of nitrobenzene, that is in the presence of this particular group, we are developing a polarity over the benzene ring, and over the ortho position we are getting a positive charge, we are getting a positive charge. See, here we were getting a positive charge, and here over this particular carbon, that is the ortho position, we are getting a positive charge. So ultimately this NO2 is deactivating the benzene ring, means it is decreasing the electron density from the benzene ring, it is pulling out the electrons, okay. So if any group that decreases the electron density over the benzene ring, it decreases the electron density on benzene ring. So from which positions of the electron density on benzene ring? At position at ortho and para position. So at ortho and para position, this has decreases the electron density, so pulling the electron density from the benzene ring. So these are known as the deactivating groups. So why we are saying the deactivating groups? Because if my electrophile wants to come, and if my electrophile wants to attack over this nitrobenzene, so guys, this is like and this is like repels. So will my electrophile will be more reactive towards this benzene? No, the electrophile is now saying, okay, what I would get when I will come to you. So it is getting repulsion, like repel, okay. So that's how we are saying that it is a deactivating towards electrophile. So when we will try to attack the electrophile over such a group, there will be a deactivation. So this particular group has deactivated the benzene ring towards the electrophilic attack, because now this particular group doesn't want to react with the electrophile. So that's why this is known as deactivating group. Okay, now the question is that why it is known as the meta directing? Guys, this is known as the meta directing because of one certain reason. If in case this electrophile says no, I want to attack, I want to react, now which is the position where this electrophile can react? This electrophile, in the presence of this particular group, this electrophile can only attack at this particular position, because if you would see relatively we know benzene as an individual is nucleophilic, okay, but because of this particular group these positions are getting positive, so ultimately relatively this is more negative. So relatively this is more negative, means more electronegative, and opposite attracts. So that's why the electrophile will prefer to go over the meta position. This is your meta position, so that's why we are saying that such a group is known as the meta directing. Okay, so such kind of group will be known as the meta directing in nature. Guys, if you will put any of such a group, okay, no matter that this is oxygen, now you tell me, if I will be having a benzene but with an O positive, so what this will oxygen will do? Now oxygen is saying I'm a deficient, I'm having a positive charge, being an electronegative atom carrying a positive charge is very difficult for me, I'm very unstable. So ultimately this will ask for the electron pair to move towards me. So ultimately when the electron density is moving towards this group, means this is pulling the electrons from the benzene ring. Ultimately it is a deactivating group, and it is a deactivating towards electrophile. Ultimately we will be getting a positive charge over the benzene ring. So any of the atom if having a positive charge, definitely, because it will again try to pull up the electron towards itself. The group like NO2, the groups like cyanide, of course the cyanide is also the example of the minus M effect. Why? If you would draw the structure of this cyanide, you know carbon has 4 valence shell electrons, 1, 2, 3, 4, all are getting bonded like this. Now if you would see the conjugated system, now if you want to see the polarity that has been developed between this conjugated benzene and the carbon and the atom which is directly attached to the benzene ring, then we would see that this polarity is developing in this particular direction, ultimately we are getting a positive charge over this and the negative charge over this. So here my benzene is getting more positive, and hence my electrophile is also positive. Electrophile means deficient, so like repels. So ultimately this is getting deactivated towards the electrophilic cutting. So this will also be known as the deactivating group. So if you put any of the group, if you put SO3H, again the same thing will happen. If you will see the SO3H group, this is a benzene. Here we will be having S double bond O, and this will be O and H. So here where you have to see the OH part. No, you just have to focus over the conjugated system and the directly attached atom, this atom and this conjugated pi bond. Okay, so where the electrons are getting transferred. So guys, here we know that this is X, this is Y, this is Z, and over this Z these are the pi bond. So choose any of one of the pi bond. Ultimately this is going in this particular direction, because we know that the sulfur and oxygen, this is a polar pi bond, and being oxygen more electronegative will pull the electron towards itself, and ultimately this bond will go like this. Ultimately we are getting a positive charge over the benzene ring. So whenever we will be getting a positive charge over the benzene ring, whenever the electron density of the benzene decreases, so whenever there will be a decrease in electron density of the benzene ring at the ortho and para positions, this will be known as the minus M effect or the deactivate. These such groups are said to be the deactivating groups or deactivating towards electrophile. Okay, now where the electrophile, tell me where this electrophile will prefer to attack? Meta, because relatively meta is more negative, so this will choose meta. Okay, so guys, this is it. Now let's have a look over the another part, that is a very good comparison that I will be showing to you, all of you. So what does this say is, let's have a look what I want to tell you. So here I have taken 3 examples. Okay, so what we are doing the comparison, we are looking for the already attached group Y. Okay, so what do you mean by this Y? Y is particularly this atom which is directly attached to the benzene ring, this atom which is directly attached to the benzene ring. So here we have to focus. Okay, this decides the position of the incoming electrophile. So this is going to decide, this particular Y groups are going to decide these are the Y groups which are going to decide where the electrophile will attack. Because electrophile choose which position? Electrophile choose a position which is more negative in nature. Okay, where we have more electron density. So when I look for this particular compound, this is my benzene ring, so I want to see that what type of effect this group is causing over the benzene ring. So here we found that, okay, this double bond and this nitrogen, this is a lone pair. So ultimately, if you would see between a pi bond and any of the atom with a lone pair, of course the direction would be this. This will increase the electron density over the benzene ring. Ultimately, here we got a negative charge, then this negative and this negative. Here we will be getting a negative charge, then this negative and this pi bond. Again here we will be getting a negative charge, this negative and this pi bond. Here we will be, this will be getting neutralized, this positive charge will get neutralized. Okay, so this is what we got. Okay, so here my electrophile will attack where? If I want my electrophile to attack, my electrophile will attack at this position, at this position and at this position, that is ortho and para. So ortho and para directing groups are known as the plus M effect. This is causing plus M effect. This is ortho and para directing. Now let's have a look over this particular carbon. So this carbon, we want to see how the polarity is developing, okay, between the adjacent atom and the conjugated system. So this is my conjugated system, this benzene. So this benzene and this carbon, so how they are behaving? Over the carbon we don't have any negative lone pair or any positive charge, but we do have a pi bond, okay. So the electron transfer of a pi bond could also occur. So this pi bond and this pi bond, how they would be behaving? This is a polar pi bond which will be breaking the bond in such a direction. Ultimately this pi bond will also be broken in such a direction. Ultimately we got positive over there. Okay, now this pi bond will be broken. We will be getting positive over there. This positive and this again resonance. When this movement will occur, we will be getting positive over there, and this positive and this double bond again will show the resonance. Ultimately here we will be getting a positive, and this positive and this negative, this is a temporary effect, that is the electromeric effect. So they will prefer forming a bond together. Okay, that's why this pi bond has been formed. So ultimately, now you tell me, if I want my electrophile to attack, where the electrophile will attack? Ortho position, no, positive positive repels. Ortho the para position, no, positive positive repels. So this position is not reactive, this position is not reactive. Only the position which is meta, which is free, which is having relatively more negative. So here this is meta. At meta this will attack, meta product will form, meta product will form, okay, because relatively meta is more negative, meta is more negative, here also meta is more negative relatively, right. So ultimately last above 3-1, okay, achievers, I will be taking your doubt, as I said, no, at the last I will be taking all your doubts, okay. So here this meta will attack, and here we will be getting a meta product. Are you getting? No, relatively ortho and para are not reactive, so ultimately meta we will be doing an attack. So this is known as the minus M effect, because here we are getting the meta directing product. That's the reason. Okay, now if you would see here, so this is again my conjugated system, and I want to see in this conjugated system and the atom which is directly attached to this benzene ring, what kind of polarity is getting developed. Now guys, over this oxygen we have a lone pair, so whether this lone pair will undergo resonance or not? Of course they will undergo resonance, because we know that lone pair always undergoes resonance, lone pair always undergoes resonance in this such a direction. So ultimately here the electron density increases, we are getting negative over the benzene ring. So the benzene ring electron density is getting increased. This negative and this pi bond will do the conjugation in such a way, we will be getting negative here. This negative and this pi bond will do the conjugation, we will be getting negative here. So if I am moving my electrons in such a way, guys, you know, nucleus never moves, always electron moves. Electrons are only mobile in nature. So until unless you don't do this kind of movement of electron in organic chemistry, you will not be able to learn it, you will not be able to understand it. So I would suggest, please pick your pen, try to do this movement again and again, and you will be able to do it. And always remember, whenever there will be a resonating system, there must be only 3 atoms attached, that is X, Y, Z, and over the Z negative, positive, lone pair, pi bond, any such thing could happen. Okay, so this is it. Ultimately this negative and this positive, because over this positive this will get neutralized, ultimately we neutralize this and we got this as a bond formation. So here what we have noticed, now if I want my electrophile to attack, where this electrophile will go? This electrophile will prefer to go at ortho and para position. This is your ortho position, this is your para position, this is your again ortho position. So this is also ortho and para directing. If this is going over the ortho and para position, this is said to be the plus M effect. And we can also say that this is also activating in nature. Why activating in nature? Because this is increasing the electron density over my benzene ring. Okay, so ultimately we can name such kind of groups, we can distinguish all such kind of groups that they are ortho and para directing, they are meta directing, and so on. Now, just to clear all the confusion that you could have, है ना, in very least scenario, if I would consider that you are still having a confusion, that confusion can be clear by my these two examples. One of the example would be this. We will be having a benzene with NHC double bond O CH3, and the another example would be benzene C double bond O NHCH3. Guys, what type of difference that you can notice from these two compounds that I have drawn for you? Last above freon. Just give me a while, achievers. Okay, I will take your doubt. Don't worry. Okay. Okay. Can you see? Do you understand that why I said that this is going to be a plus M effect and why this is going to be a minus M effect? Are you getting it, guys? So the plus M and minus M effect can be best compared, can be best understood by these two examples. Yes? Do you all getting my point? Why this is plus M and why this is minus M? Because we have to see the polarity between the conjugated system and the atom, which is nothing change. Nothing change. There is a much change. This is NHCOCH3 group. This group is NHC double bond OCH3, and this is C double bond O NH and CH3. There is a much difference. Okay. Much difference. This is a kind of amide and this is a kind of methylated benzamide. O will be O negative. O will be O negative and will cause different charge on atom attached. Okay, and what about the group which I have written in the plus M section? What this will do? Tell me. See the comparison in between the two. Now this is your job to do. I was teaching you from last 20-25 minutes. Now it's your turn to answer me. What is the main basic difference between the two structures and why it is plus M and why it is minus M? I was repeatedly saying you have to see the polarity between this group and the conjugated system. So what type of polarity is getting developed between this part and this part? See the polarity, and wherever we have to see the polarity, what was the definition? Again, come to the first page. We have to see the polarity develop between the atoms of a conjugated system and the adjacent atom. So what is that adjacent atom? Polarity between the conjugated system and the adjacent atom. Okay. So between the conjugated system, this is your conjugated system, and the adjacent atom. So what this nitrogen is doing, I need not to bother that what this part is doing. I need not to bother what this part is doing. My whole focus has to be over the atom which is directly attached to the benzene ring. That is the adjacent atom. Again and again I am saying the adjacent atom, the nearest atom, the atom which is very close to the benzene ring. Have a look over that particular atom. Okay. So now when you will see over this particular atom, this is a pi bond, this is a lone pair. So who will do the movement? Of course, this lone pair will do the movement, and the movement will be in this particular direction. Ultimately, what can happen? The electron density will increase over the benzene ring. Here the electron density will increase, and you will be getting NH positive and C double bond O CH3. So this kind of polarity will develop here in this question. Okay, so ultimately what this group is doing? This group is increasing the electron density. This group is increasing the electron density on benzene ring. At what positions? At what positions? Of course, now this will go there, this will go there at this position, this will go there and this will go there at this position. So where the electron density is increasing? The electron density is increasing over the ortho and para. So if my electrophile wants to attack, where the electrophile will attack? The electrophile will attack at ortho and para. So this group is ortho and para directing group. So this group is ortho and para directing group. Okay, so if this particular group is increasing the electron density over the benzene ring, so this is said to be the activating group, and this is activating group for what? Activating group towards electrophile, got it? And this is ortho and para directing in nature. Now if I ask you to compare between this particular structure, that is this. Now what do you have to see? Again you have to see that what type of polarity is developed between the group and the conjugated system. The conjugated system polarity, the conjugated system and the adjacent atom, this adjacent atom. So what type of polarity they will develop? Over the carbon, do we have a lone pair? Do we have positive, negative? No, nothing. We have this pi bonded electron. So how the movement of electron will occur? So if we have to see the polarity, so the polarity develops by what? By the electron transfer or the pi bond present. So please focus how this electron transfer or the the electron transfer between this pi bond will occur. Now please have a look over this. So we can see that this is a polar pi bond. So the movement of this pi bond will occur in such a direction. Yes or no? Because oxygen is more electronegative, this will break the bond and pull the electron towards itself, and this will go in this direction. Ultimately what we can focus here is this will become positive, and this is a carbon. Let me again write it for you. So here these two bonds will remain the same, this will become positive, and this carbon, between this carbon and this bond we will be getting a double bond, this will become O negative, again it is getting messy. Yes, this is getting O negative, and this is the part that will remain the same. So guys, you need not to bother about the rest of the part, that whatever we are having, you need not to bother about that particular part. You just please have a focus that what this particular atom is doing. Okay. Now in the second case, in the minus M effect, what is happening? The electron density is decreasing from the benzene ring. Electron density from the benzene ring decreases. So here this bond can also move like this will become positive, this bond can also move like this can become positive. So ultimately this group is doing what? This group is, if my electrophile says, oh no, I want to attack over you, so this electrophile will be able to attack over the benzene? No. So the electron density from the benzene decreases, means this group is making my benzene deactivated towards the attack of a new electrophile. So this is getting deactivated. So my benzene is getting deactivated towards the attack of electrophile. So we can say that this is a deactivating group. If in very rare scenario, if my electrophile says no and start crying, no, I want to attack, then where this electrophile can go? Only at meta position. This can only go at the meta position, because relatively only meta tag is possible. So we can say that such groups are meta directing in nature. Is it clear? Okay, guys, पता है many times you people get confused by this particular part कि ma'am here also we will be having something, here also this nitrogen will also do something. So what I'm saying, so whenever you are putting the mesomeric effect, ignore this part, because this could be a resonance, but here we are looking for mesomeric. Okay, so if you will look for this nitrogen and this double bond, so basically you are looking for the resonating system, you are looking for resonance to occur, but we are talking about mesomeric effect there. Okay, so in the mesomeric effect you have to see the polarity that has been developed between the conjugated system. Conjugated system is said to be the system where we have the multiple conjugation, there will be the complete delocalization like a benzene kind of system, okay, and the atom which is directly attached to it. Okay, so if you are focusing over this particular part, please ignore this part, to decide that what type of effect this group is causing. Clear? Okay, so I hope the point which I want, many times you might have studied about the resonance and the mesomeric effect, the plus M and minus M effect. Many times you might have studied in your club, in your school, in your classes, in your tuitions, or anywhere in books. But you understood that what point I want to clear, where you people were confused from so long, and if I made it possible somehow, then yes, this is my success. Is it? So guys, if you have any doubts, I would be ready to take. Okay, if you would have any doubts, I would be ready to take. Please come up with any of your doubts and we'll have a discussion on that. If you want me, ma'am, please put this such a group and then tell me what will happen. In that case, yeah, suggest me any group that you want to see. Okay, that ma'am, I always get confused with this group, whether this is plus M or minus M. So at the last, one more point that you can note down, कि whenever we have any kind of functional group, then always the mesomeric effect dominates. Mesomeric effect, because along with the mesomeric effect you would also see the inductive effect. So mesomeric effect dominates over inductive. Generally, we can say that generally the mesomeric effect dominates over the inductive effect. Okay, you have to consider the mesomeric effect over the inductive effect. But in cases of halogens, whenever you have halogens like fluorine, chlorine, bromine or iodine, because they are highly electronegative, okay, they are relatively more electronegative as compared to that of the carbon, their inductive effect dominates. So whenever you have such a question, that ma'am, if we are having a benzene and we do have a chlorine present over it, then what can happen? Of course, if you would see the chlorine lone pair will go in such a way, this will be an activating group. If you will see the mesomeric effect, yes, this is an activating group, this is said to be the deactivating group, but this is weakly activating. Very weakly activating group. Why this is very weakly activating group? Because chlorine is highly electronegative. So here in the case of the chlorine, the inductive dominates. As I said, the inductive dominates. So if the inductive dominates, inductive is the polarity along with this single bond. Okay, so ultimately this will be negative and this will be positive. So this is withdrawing in nature. This is showing minus I effect. Okay, so this is very weakly activating, but if this activates the attack of a electrophile, so where the electrophile will prefer to attack, so yes, the electrophile will prefer to attack at the ortho and the para positions only. This is also ortho and para directing in nature, ortho and para directing in nature. Yeah, yes, absolutely, Karthik, because there the halogens are strongly electronegative, comes in group number 17. Okay, so this is it. So everything clear? I hope this session has helped. So if you have actually learned the point that I want to make it clear through this session, then please hit like, and if somehow somewhere you missed out any of the thing, I would simply suggest watch this session recorded, because many things, many important things I have repeated multiple times. So after this session you need not to watch any other session on the same mesomeric effect. Okay, so guys, this is it for today. Thank you so much. You do hit like and subscribe for this channel and share this session if it helps you anyway. Guys, you can follow me on Unacademy. There I am taking many of your plus sessions over the Unacademy Plus. I am a teacher over Unacademy from last 5 years. I do have 1 million plus students, those who are learning from my classes. This is 127k, means 1,27,000 plus students are learning from my courses. I do have 6,000 plus dedications from my students, those who have wholeheartedly dedicated their hats to me. And I do have a 332 million watch minutes, means I have been watched this much of time. Okay, I may be new over the YouTube, but I am teaching you for this ITJ category from last many years and has produced many such ranks. So guys, if you want to learn from us, come over there Unacademy. That's a wonderful educational platform that could help you a lot in your preparation and can build and can give you the interest in whichever the subject you want to, because we do have multiple teachers with multiple talents. Okay, so come across. You can even use my code, which is Megha ma'am, and get the Unacademy subscription at the reasonable cost. You will also be getting a discount that you will, it's basically my referral code, and this will be giving you a certain discount as well. Okay, so if you want to unlock any of the free session of Unacademy, whether it's my special class or any other free course that I have created over Unacademy for you, yes guys, you can unlock it just by using a referral code, which is Megha ma'am. So this is it for today. Do follow me and keep watching my lectures, and definitely I guarantee you, you will keep on learning and you will keep on building your interest in the subject. Bye, take care.